What I want is this sort of Elm-like experience, but for this sort of long tail of domains, like, web servers, but also like command line apps and native desktop GUIs and maybe mobile apps, robotics.
Hey folks, welcome back to Elmtown. I'm your host, Jared M. Smith. We'll be visiting with the always ambitious Richard Feldman today. Richard needs no introduction. He's done a lot for the Elm community, but if you're new, just to give a kind of rundown of some of the things that he's done, he is the creator of the Rock programming language and host of the Software Unscripted podcast. For folks, I'll set the context with he's been an instrumental force for the rise of Elm. Some of his contributions include iconic talks such as making impossible states impossible and scaling Elm apps. He's given over 100 hours of teaching Elm in person. He's written a book, Elm in Action, presented 2 video courses on front-end masters. I asked him to join us to talk about how Elm inspired Rock, the fast, friendly, and functional programming language that's, quote, a direct descendant of Elm. Richard, welcome to Elmtown.
Thanks for having me.
Thanks for making the trip from Rock City.
I wonder where Rock City is. There's got to be some city somewhere named Rock City. I'm sure that exists. Probably spelled differently.
Yeah.
Rock with a K.
There's at least Detroit Rock City. So
there you go. That's true, yeah.
Okay, so to get started, I won't go through your full history. I think there's a podcast I will link to, an episode you recorded with Lindsay Wardell on Modern Web, where you kind of give more of the history of kind of getting started with programming in general. But what experiences did you have leading up to the decision to make Rock, and guide us from there, the story of how it came to be?
Like you mentioned, Rock is a direct descendant of Elm, and I would say that the 3 main motivations that led to wanting to make Rock were, 1, wanting to use an Elm-like language, not necessarily literally Elm, but a language that has, I don't know, what felt to me like the sort of essential parts of Elm that I was looking for in sort of other domains. So besides like front-end web development. So that was one thing. I sort of knew that like Evan's approach to Elm is like, if we're going to go into a domain like front-end web dev, or like Elm on the server in Evan's vision is, I think, really, really ambitious and exciting, and also different than what some people are looking for. Like for some people, it's like, this is amazing. This is exactly what I'm looking for. And for some people, it's sort of like, I want something slightly different than this, or very different from this. So my feeling was like, okay, if Elm is never going to target like Vim extensions, for example, like that's just never going to happen. That just wouldn't make sense for Elm. But whenever I sat down to say like, oh, I kind of want to try writing a Vim extension, I'm always like, I don't want to write Vim script. And then, NeoVim now has Lua support. I'm like, I don't really want to write Lua either. What I want is this sort of Elm-like experience, but for this sort of long tail of domains, like, web servers, but also like command line apps and native desktop GUIs and maybe mobile apps, robotics. Like there's all these different use cases where when you look at what's available in terms of programming languages, it's usually like, well, maybe you got like Lua or a JavaScript or like Python, but never really anything Elm-like. So that was sort of a missing piece for me. Second motivation was there were some ideas that I had that for one reason or another were just never going to make it into Elm, and which I kind of wanted to try out. So in some cases that might be like, this is a reasonable idea for Elm, but it's sort of too late. It's like, if you tried this out on day 1, maybe you could, see if it was good or not, but it's just like Elm's, it would break too many apps to try this out now. Another category of things where I talked with Evan about it, but it was sort of like, it fit my style, but not Evan's style. And so like, you can only pick one way. Obviously it's going to be Evan's way. So those are some things that I was just curious to try out. So the big one there I would say is Rock doesn't have currying. And I talked to Evan about that. I was like, hey, I don't think, Elm needs currying. And to make a long story short, Evan was not into that idea, but I was. So that's one of those things where you can only have one or the other. So I was curious to try things in that area. And then the third category of reason that I wanted to make Rock was just, I was nearing the end of writing Elm in Action, and I was really looking for another like big project to sort of sink my teeth in that was going to take a lot of time to work on. A programming language sort of obviously takes a long time, but that was kind of an exciting thing for me. It wasn't like a downside. It was like, no, I actually really would love to do a really big, like long-term ambitious project like this. So those are kind of the things that led to deciding to make a programming language.
I wanted to ask about the timing here. I believe according to the Rock language webpage, there's the year 2018 on there. Is that when you started actually writing code for it?
That's when I started designing it. That was sort of when I decided, like, okay, I'm actually going to do this. And so I had this sort of general idea of like these goals that I mentioned, but I didn't really have any idea of how specifically that would turn into a language. One of the things that's really cool about Elm is that, and that I've always like sort of admired about it, is that it's really focused on this one domain. And then within that domain, everything makes sense. Like you don't have these weird primitives that you have to ignore. Like, for example, if you look at Rust compiling to WebAssembly to run in the browser, you have all these operations in the standard library that are around like file system IO. They just don't make any sense in the browser because you don't have that there. And I think for every different domain you can pick, you're always going to have some stuff like that, where some primitives make sense and other primitives don't make sense. And so I was trying to think, how can I sort of generalize this? Like, if we're not going to make a language that's focused on one domain, how can we make it so that we can still get that sort of Elm-like experience of all the primitives make sense for the particular domain we're targeting? So this is where the Rock's like platforms and applications design came in, which we can talk about that later. But that's an example of something that I came up with in 2018. So the first line of code was actually January 2019. But there was like quite a bit of design time before that, trying to figure out like, okay, concretely, what are the things that, you know, I want to put in this language.
Yeah, I definitely would like to talk a bit about platforms, but kind of still going back to this timeline and the motivation here. 2018, you were working at NoReady, correct?
Yes.
And you were using, of course, Elm on the front end. By then, I'm sure you had quite a few 100,000 lines of Elm code.
Oh, yeah.
And were you also using Haskell there?
The timing here is definitely relevant because I don't remember if we had started using Haskell or not. But one of the things that's definitely true is that the decision to use Haskell on the back end was one of the things that made me say, okay, I'm actually going to make a programming language. And the reason for that was essentially we had done this search where we were saying, okay, we're unhappy with Ruby on Rails on the back end. We want to move to a different language, a more functional, statically type checked language. And we wanted something that was sort of simple like Elm, like a simple type system and, you know, simple type system, purely functional, and, you know, but a language that's for backend web development. And we really couldn't find anything that sort of fit all of those criteria. And so what we ended up going with was essentially Haskell, but try to do it in like an Elm style. The reason I say that was one of the motivations or one of the things that led me to conclude I should actually make a language was that in that search, I was like, why doesn't this exist? Like, how is it that, you know, this doesn't seem to be a thing that anybody's working on? And obviously there's a lot of languages that almost fit that criteria. Like you could say, oh, like OCaml's a good backend language. It's like, yeah, but it's not purely functional. And you do have this whole like object system that everybody just kind of pretends isn't there, like kind of ignores. I wasn't really looking for that. It's like a nice thing about Elm that is, you know, really nice in terms of, I don't know, ergonomics, but also just in terms of the feel of the language is that there's no like Elm the good parts. You know, it's not like, oh, only use this subset of the language. It's like, no, actually the language is just small in a way where all the pieces fit together and are useful together. So we, you know, that was like kind of a problem with OCaml. You know, F# you have again like another set of trade-offs. You know, Haskell has its own set of trade-offs. PureScript has its own set of trade-offs. And we really talked about absolutely anything. But in the end, it seemed like, well, let's just use Haskell and try to use a subset of it was sort of like the option that made the most sense for us. But at the end of the day, I felt, look, there's people out there who want to do, you know, who want this experience to be good and not just sort of trying to take another language and use it in a way that it's not really designed to be used.
That's really interesting. Yeah, I think Haskell is made in a way that made it possible for you to build an Elm-like Haskell, right? But at the same time, there were probably a lot of things that you had to decide where it was like it was almost like you got to play around with building a language, right? Like you're like, well, we want Elm, but we're going to use it in this particular domain. And so, these are the particular pieces that we want to fit in there. Did you feel like you were sort of designing that? Like this was like a precursor to building? You're like, wait a second, like I'm almost doing that.
I didn't really personally have a hand in that aspect of it. So I know like several people worked on the sort of our custom prelude, which is sort of the Haskell standard library variation. There was a mix of adding new things. So like the pipe operator, for example, and then sort of removing things or saying like, let's not use these things. So it's like simultaneously only using a subset of Haskell, but then also adding some other things that, Elm had that we were missing. So given that I didn't personally work on the sort of the design of that standard library, it wasn't really not really a motivation, but it wasn't, for me, it didn't feel like that was like really related to Rock. The main way that related to Rock was just sort of the realization that like there's a missing piece out there in the world. And like, even after Evan ships his sort of vision for Elm, quote unquote, on the back end, which is not what most people, sort of think of when they hear that phrase, I figured there's still going to be some percentage of people who want the sort of more traditional, arguably less ambitious version of a backend server.
Right. Okay. Yeah, that makes sense. So, yeah, the motivation seems clear here to me, and I think that fits with a question that I often ask: is what is the Elm equivalent on the back end? And so that's your answer to that, right?
Well, I would say, so like I said, Evan's got his sort of design for Elm on the back end, and Evan's design is, I think, mostly based on the observation that if you look at, like, you have an Elm front end, and then you have a database, and obviously the database is necessary for persistent storage across multiple sessions and things like that. So both of those pieces seem like essential if you want to have like, you need a user interface and you need some sort of persistent storage. And Evan's observation was essentially, okay, then you have this web server in the middle. Like, what is it really doing? Right? You have it's like, well, the UI sends some data to the web server, usually JSON, and then the web server turns around and sends decodes that JSON, and then turns around and says, okay, let me turn that into a database query. And then the database comes back with this data, and then the web server turns that back into JSON to send it to the client. So like, what's your job really? What's the essential value that you're really providing here? And in that design, it's like, yeah, is that really a thing? And so Evan's kind of idea was, could we just get rid of that and just have, essentially a Postgres extension or something like that, where you're able to just write only Elm code and it's taken care of sort of end to end. And then you're just describing in the client, like, here's what data I want to get out of the database. And then on the database, you have some, Elm code running that's taking care of authentication and all that stuff. And then that's it. And you've simplified your whole stack, and a lot of sort of problems and potential pitfalls go away. That's really cool. That's really exciting. Like, I think that's how a lot of applications just ought to work. It really makes a lot more sense than like the traditional model that we have in the web world. Having said that, like I said, there's also some percentage of people are never going to get on board with that for one reason or another. And I'm not saying they are or are not correct, but rather that, if nothing else, I feel like having that option out there means that they're not, at least they're not saying, oh no, I still feel like there's this missing piece, or like, Evan, when are you going to add the more traditional thing to go on top of the thing you actually want to make? So I see it as sort of like, this is not necessarily the obvious answer for people who want to, who like Elm on the front end and want to have an Elm-like back end, but rather that it's like for people who want the Elm-like front end, and then for one reason or another, the thing that Evan's making, don't make sense for them.
Right. Yeah, I guess what I'm thinking of is maybe on other platforms, right? On a more general set of use cases where it's like, well, maybe I want it to be inside of a container on a, something on AWS. Like, you want to have that control of where you place that. I think that there's a more sort of industry expected direction. And so I think, of course, Rock is ambitious in a lot of different ways, but something that platforms make possible is this ability to say, yeah, do I want to build a Vim extension, or do I want to build a web server, or do I want to, whatever the case may be, and use this particular language. So
one way to say it is that if you're trying to migrate from an existing backend, like Nowhere Inc. is in that position, then one of the advantages of this approach is that it means that you can not only have a like one option that you can always do, which is what we ended up doing with Haskell, is you can have sort of a separate server that runs the new language, and then the front end talks to some combination of the new and the old. Or in Rock's case, you have the ability, since Rock is quite good at being an embedded language, where you can sort of run it in the same process, the idea would be that you can have more granularity there. So you can say, for example, I can, from my Ruby code, just more directly, more easily just call a rock function rather than having to have a whole separate service and stuff like that. And that is something that's possible with Haskell. So Brian Carroll actually made a little proof of concept of doing direct Ruby to Haskell FFI. I don't actually know if that's in use in production, but it is definitely possible. But Rock is designed to be sort of good at that, whereas Haskell, it's like it supports it, but I don't know if that's something that is, I don't know, really an intended use case, I guess.
So let's talk a little bit then about what Rock is and how it compares to Elm.
The biggest difference between Rock and Elm is just that Rock compiles to machine code and not JavaScript. And that's by design. And some we get asked periodically, like, hey, when will Rock compile to JavaScript or to the Beam or JVM? And my answer has been consistently like, I don't want to do that. It compiles to machine code or WebAssembly, which is kind of more portable machine code. But that's sort of the level of abstraction we want to target. So basically, that has a couple of interesting implications. So one thing that people commonly say is, oh, couldn't Rock just compile to WebAssembly and then you could run it in the browser, which technically is possible. But one of the things I learned from Elm is that targeting the browser is a lot more complicated than just like, oh, you literally have something that's able to run in the browser. There's just like a lot of considerations and a lot of care that has to go into doing something like that. One thing that I discovered, a couple of years ago, is that if you want to do the Elm architecture in Rock, it actually doesn't really work, or at least it can't work quite in the same way for a couple of reasons. So one is that lazy in Elm HTML relies on using persistent data structures behind the hood. Under the hood. And if you don't have persistent data structures, then you can't do the cheap reference equality check to see if you can skip rendering a bunch of stuff. Now, Rock does not use persistent data structures, which arguably maybe this is actually the biggest difference. I don't know. It's one of the two, compiling to machine code or the lack of persistent data structures. But one of the other experiments that we're trying in Rock is this idea of opportunistic mutation. So basically, rather than having persistent data structures, so like in Elm, you have like a persistent list. It's like a persistent linked list for your basic sort of sequential data structure. And then you have like dict and set are also both persistent data structures. And in Rock, none of those are the case. So in Rock, instead, what we have is essentially once you create some sort of Rock value, initially it gets a reference count of 1, meaning only one thing is referencing it. Later on, it can get shared in multiple places, but if it ends up that you try to do something like a list.set to set some particular element to a particular value, then it's not going to it's either going to like deeply clone it, or if there's only a reference count of 1, then we know, well, look, nobody else is referencing this, so if we just mutate the one that we've got, nobody's going to know, and then return that one. Like it's going to be unobservable. And so the idea here is that hopefully, and so far this has turned out to be accurate, thankfully. The idea is that this lets us, in practice, get a lot closer to, or even compete with languages that have like imperative, just mutate everything type of performance. However, this does have a downside of certain things that Elm does, like lazy, don't like just work the way that they do in Elm. So there's sort of a different set of trade-offs there. And so as a consequence to this, this means that Rock is maybe useful in a different set of domains. And personally, I'm fine with that, because although another thing I get asked about is like, hey, I want to do, Rock in the browser because I want to have the same language on the front end and the back end, which personally I think is kind of overrated, but whatever. I do think that it's a relevant consideration that you're not going to get the same exact Elm experience even if somebody did create like a virtual DOM Rock thing, just because there's just different trade-offs there. So yeah, it's a complicated landscape.
Yeah, that's really interesting, though. So, of course, there are ways that Rock diverges from Elm, but are there any particular principles from Elm that continue to guide Rock, in which you've said no to certain things because of those principles?
I mean, definitely the biggest principles to me are sort of aiming for a sort of small set of simple primitives. I mean, like Elm's logo is the tangram because it's a small set of simple primitives that you can make surprisingly many things from. Rock's logo is sort of an homage to that. It's an origami bird because a rock is a type of mythical bird, and that is ROC is a mythical bird. Also spelled RUKH, depending on which language you look at. But At any rate, it's a mythical bird, and origami, like tangrams, are, origami is like similar but not the same to tangrams, but they have that shared sort of foundational thing where it's like you have a small set of simple primitives that you can make surprisingly many things from. So basically, I think that is the essence. If I had to pick one thing, is just small set of simple primitives. One of the things that Rock does do differently from Elm is we have a different set of, I guess, like stylistic things. So partly that's some syntax sugaring the language that's a little bit different from Elm's. So we recently introduced this exclamation point operator, which is for chaining tasks together. Chaining tasks together comes up a lot more often in, like, if you're not using Elm architecture, because like in Elm architecture, oftentimes you're chaining things together with like commands and messages and stuff. And so like, task.and then it comes up, but it's like not that common. Whereas if you're making like a sequential script that's just doing a bunch of IO, it comes up constantly. And so for use cases like that, which Rock is targeting, that's something where we have a real need for, or maybe a lot more of a demand for, like making that really concise. So we just added that pretty recently, and that's been like a big hit. But that's something which I don't think Elm needs that. I don't know. I mean, yeah, you could do something like that, but it just wouldn't come up that often. Similarly, we also have some different stylistic choices, which kind of just have more to do with my personal preference, I guess. So like records use colon instead of equals for the fields. Personally, I like equals being reserved for assignment and not being in there for records. Like, I think both are reasonable, but that's just a little personal preference. We also have like trailing commas instead of leading commas from the formatting perspective. And like that's actually how I used to do things in Elm, like originally when I first started writing Elm before Elm format existed. That's that's how long I've been using Elm. But when Aaron started working on Elm format, he was, well, actually, so the way that this happened, we were at the Elm meetup in San Francisco, and there were two people, Jeff Smits and Aaron Vonderhaar, who were there. And Evan had been talking about how we should have something like Go Fumped, like Go format, because it's like a really cool thing. And I didn't really know Haskell, so I didn't feel comfortable trying to write that, but I was really excited about the idea. And I was talking to Aaron and Jeff about that and saying like, hey, you guys know Haskell. Do you think you'd be interested in collaborating on making this exist? And Jeff said, well, I'm going back to Amsterdam in a bit, so I'm not going to have bandwidth for that. And Aaron said, I think I could solo it, but I need a spec. And so I was like, oh, cool. Well, I know that Laszlo Pandy wrote this Elm style guide, so if you want, I could just sort of translate that into a spec. So I basically just like wrote up like a detailed specification from that. And Laszlo had said like, okay, we're doing, trailing, leading commas rather, like commas at the beginning of the line, etc. So even though that wasn't my personal preference, I was like, this is, the idea is like, let's just like have something consistent. But I figured like, if Rock's going to be different from Elm, then I could switch it over to my preference. It'll be fine.
Right. Okay, cool. Yeah. So I wondered what the origin of the Elm style guide was. So that's good to know. I hadn't heard that story before.
Yeah, I'm sure you could find it somewhere. Like Laszlo, I think wrote it in like 2013, 2014, maybe. Maybe he was Evan's manager at Prezi. It was like Evan reported to Laszlo, who reported to the CTO.
Oh, okay.
Yeah. He also made the first version of the time travel debugger. Laszlo did.
Right. Yeah.
Yeah.
Cool. Going way back.
Yeah. There's a video online of Laszlo presenting the time travel debugger somewhere.
Yeah. I think that used to be on the Elm website, wasn't it?
Yeah. I forget what the URL was. Yeah.
Yeah.
The Mario demo.
Yeah, exactly. That's cool. So I want to go back to what you were saying about this particular operator, because I wanted to mention an article that you wrote recently called Functional Semantics in Imperative Clothing. I'll put that in the show notes, but I think that's a good demonstration of why that particular tool is useful. And so, yeah, I'll put a link to that.
Yeah, that's a great example of like Rock wanting to target different domains than Elm. It was like literally we had a bash script. It was like a .sh script, and we wanted to port it to Rock. It's like, I mean, you could port that to Elm, but like, it's not it's not really what Elm's designed for. Whereas Rock, like that is actually something that I've always wanted Rock to be good at. Is like I would like to be able to just write the scripts, and at the end, like after we added that syntax sugar, it ends up looking like basically the same as the bash script, except I think actually a little bit nicer, in part because we have much nicer conditionals than Bash does. And then, you get the full power of like everything's statically type checked and type inference and, functional style and all that good stuff. So yeah, that's that to me was like a really exciting moment for, I mean, it's like a Bash script. It's like, who cares? But, but I was excited.
Yeah, I think it is exciting. It's just a good explanation and simple enough that it's easy to grok. So yeah, cool. So I wanted to now talk a little bit about how you govern Rock compared to Elm, and particularly because of something that you said about how you want to keep a small number of primitives. And one of the things from the page about governance in Rock is, quote, you want to find a system which minimizes the erosion of simplicity. You want to talk a little bit about that?
Sure. So I think the page you're referencing is /BDFN on the website, rocklang.org. Yeah, so I use this term BDFN, meaning benevolent dictator for now. So basically, my plan is that I want to initially, like while the language is sort of, getting up and running, be the like benevolent dictator. So basically the way that works in practice is like we kind of like everybody who's involved in Rock, like the sort of core contributors, we don't have like an official core team or anything, but the people who've contributed the most, we sort of talk about everything in Zulip, pretty much, Zulip chat. But basically, I sort of have the last word. So if we can't come to some consensus, which we usually can, then at some point it's on me to make the final decision. But at some point, I would like sometime before I die, hopefully, I would like to transition that to some different model that can sort of outlast me. And my hope for that is that it can be some sort of system that doesn't fall into the trap that a lot of sort of languages that are in that sort of mode where there's not one person running it anymore seem to fall into, which is where they just eventually just creep and get more and more features over time, and just like a little bit more, a little bit more, a little bit more. And then you're, fast forward 10 years and it doesn't matter how simple the language used to be. Now it's a complicated kitchen sink language. And it seems like a lot of that seems to be the sort of default thing that happens over time to languages that have sort of a committee running them. So my hope would be that sometime, and I don't personally know exactly how this would look. I consider this to be an unsolved problem, like globally right now. But my hope would be that you can end up with some sort of, I don't know, conservancy model where the goal is try to avoid adding features at all costs. Well, not at all costs, but the challenge there is fundamentally that almost certainly the correct number of features to add to a language over time is not zero. It's just low. Because sometimes, I mean, like, you get hardware changes, right? Hardware changes can influence software changes, which can mean that sometimes it makes sense to add a new thing to a language. The environment around you is changing, so probably at some point it's going to make sense to change some things. The question is, how do you minimize that? Because unfortunately, it seems like there's often a dynamic that happens where you have this committee of, let's say, 10 people. I guess it's usually a lot more than that, but 10 people, and one person says, I want this feature added. And the other 9 people say, well, we don't want that feature added. And even if everybody has the mindset of like, let's try to minimize features added, at some point you kind of, if you have like a voting system, you end up with incentives where one person says, hey, if you vote for my thing, I'll vote for your thing. All right. Yeah. And then I can get my thing in, and, we're going to get your thing in too, but whatever, I don't care. And then one thing leads to another, and before you know it, you're adding features left and right. I don't know how to prevent that, but I hope we can figure out some sort of system for doing that. I actually think, weirdly, Evan made a really good observation about language specifications, which is he was talking about standard ML and how they had a language spec. And he pointed out that arguably that has sort of inhibited standard ML from evolving as fast as it could have otherwise, because changing the spec is like a much more challenging process when you have different implementations out there. That actually sounds pretty appealing once the language gets to that point where you want to minimize changes, where if you can get a spec out there and get multiple implementations, then that can potentially be a tool for making it harder to add things. But then again, I mean, I look at languages that have, big specifications like C++ and stuff like that, and I'm like, Java, it's like, well, they're still adding plenty of features anyway. So yeah, I don't know what to do about that, but yeah, hopefully that sort of natural erosion of simplicity, there's some way to prevent it from getting out of control. we'll see.
Yeah. Yeah. That's interesting. That does sound like a challenging problem, but hopefully one that's figure outable. I'm sure it is.
I hope so. Yeah.
So that actually makes me think about an episode of Software Unscripted that you recorded about industrial design with Greg Wilson, where he talks about how earlier on in Python's evolution, it was a good language for teaching programming. But over time, because it's become more used in industry and just simply that, design by committee process has now added a bunch of new features. And so it looks a lot different. There are always new things being added, which, yeah, of course, erode that simplicity. So,
right. Yeah.
That's
I remember thinking when Guido announced he was retiring from Python, thinking, well, so far it seems like Python has not gotten out of control, but even though it's, like a 30-year-old language, but who knows now that there's not one person at the top saying no to things, what's going to happen. And I don't know. I guess we'll find out.
Right. Yeah. So that makes me think, because Greg also mentioned another language, Lua, that has kept a fewer number of features. So I don't know the governance model there, though. Maybe that.
Yeah, me neither. I don't really know much about Lua. I know some like tidbits here and there, but I've never really used it. I don't really know.
Yeah. Now I'm curious. I have to look that up and see if it's different, if maybe that might have some influence on it. But anyway, okay. So let's move on to overcoming barriers with gaining users of a functional language like Rock. So how has your experience teaching and talking about and being an early pioneer of Elm affected how you approach solving those problems?
So, the main two ways, and these are going to sound kind of, I don't know, maybe surprising to some people. But the main two ways that they affected Rock are in two pieces of language design. So, like you mentioned at the start, like I've spent like over 100 hours in person, like in a classroom teaching people Elm. And these are people who didn't know Elm before, just like, beginners. And this is like, I did front-end masters. I did a bunch of practice runs for the front-end masters thing, where I would go on like weekends when I lived in San Francisco, and I just go to like a local boot camp and just be like, hey, come in for free over the weekend and I'll teach you Elm. Did like Women Who Code. And anyway, so I got a lot of data points around, first of all, trying different things. Like I would experiment with different teaching techniques. And then also with like, what are the things that I consistently saw people getting tripped up on? And the things I saw people getting, like beginners getting tripped up on, fell into a few different categories. So one was like they would trip over it, but they would kind of get used to it pretty quickly. So a really good example of this is the parentheses. So a really common thing that people would mess up is, out of habit, they'd say like foo, immediately open paren, and then, put some stuff in there. Maybe they'd like put commas between the arguments. But the thing is, like, if you have nice enough error messages, then people would just kind of figure that out pretty quickly and just, get in the habit. So that's fine. I think that's kind of normal learning curve stuff. The two that I thought were a bigger problem were, one is like the two biggest things that I saw beginners struggle with, where like by the end of the 8-hour workshop, I would think, they don't really get it. They don't understand how it works. One was JSON decoding. And I know, I'm personally responsible for JSON decode pipeline, so I have to take some blame for that. On the one hand, like the sort of schema-like design looks pretty nice when you're like in a big code base and you want that flexibility. But as far as a beginner learning experience, the types are just really confusing. I would sort of walk through an explanation of like, okay, now see, it's like applying one more and one more. But I could just see from people's, expressions, and like they don't get it. And even honestly, like intermediate to advanced people, a lot of the times don't understand how the types work. They're just sort of like, I don't know, it just somehow works. Just don't worry about it. Just just use the thing and it's fine. Which on the one hand, based on what its purpose is, which is to sort of look like a schema, it works for that. But on the other hand, it always bothered me that people are using it and not really understanding how it works. It just feels sort of magical. So that was one of the things that I was like, okay, is there some way we could sort of get rid of that aspect of the learning curve? Because even if you're writing, non-UI stuff, things like, serialization, deserialization come up in all sorts of different domains. So that was one piece. The other thing that I saw beginners struggle with was currying. And this is something that always comes up in intro workshops, because as soon as you have a function with multiple arguments, you have to explain why there's multiple arrows in the type. And if you don't explain that, somebody's going to ask about it. And then, so you end up needing to explain that. And again, this was one of those situations where I'd have this whole spiel that I would go through, where I would show it one step at a time. And at the end, some people would get it, but it was generally a pretty small minority. It seemed like most of the class in general would, after watching me go through the whole explanation of how currying worked, they'd be like, every individual thing you said made sense, but I still don't get it, like intuitively. And then now, to be fair, it wasn't like the end of the world, because they wouldn't generally walk out of the class totally confused. It would be more like, I don't really get the currying thing, but I don't know. It seems like not a big deal. And then eventually it would click, like much later, but or some amount later after the class was over. But again, it always kind of bothered me that it felt like I had to go through this whole explanation, and then, at the end, people would still not really get it. So Rock addresses both of these in different ways. So on the encoding and decoding side, we do have a language feature called abilities, which lets you, without going down a huge rabbit hole, basically there's a way that you can do JSON encoding and decoding, essentially using type inference. So you can just say, like, here's my user, just call decode, say I want to decode using JSON, and it'll just kind of do the same thing that decode pipeline does, where it goes through and like finds all the fields and expects them to be there the way that based on how you use it in your code. So the learning curve on that basically just goes away. You just don't have to explain any of that. You just say, like, just call decode on JSON, and it'll just take care of it for you. And then same thing with currying. It just took currying out of the language, and so there's no need to explain that either. So those are the two main ways that teaching Elm a lot, like and sort of onboarding people to functional programming influenced Rock. Now, actually, I will say this exclamation point operator really gave me an interesting new perspective, which is something I'm about to experiment with soon when I'm going to revise the Rock tutorial. The exclamation point operator essentially works like async await, or it looks like async await. It looks like the await part, except instead of saying await space and then your thing, it's like you put an exclamation point at the end. That's basically it. So it's like foo exclamation point is similar to await foo. What the piece of feedback that I got was that my explanation of this, which I explained in that article that you, I guess we'll link to in the show notes, functional semantics and imperative clothing, it's just syntax sugar. It literally desugars to the equivalent of task.and then in Elm. And I thought that was a big selling point. To me, I'm a big fan of syntax sugar in the sense that it means that you can still have a small set of simple primitives, but where you learn how they work and then you kind of got it. But you can make the code look a little bit differently. And so, it's in my mind sort of a different category of thing. If it's like, you cannot get these semantics any other way besides this language keyword, versus you actually can write this one of two ways. This one is just a convenience for the other one, because that means that I don't have to think about like the rule set being bigger, if that makes sense. It's like, well, no, this is the same set of rules that I have to keep in my head. It's just that, like, oh, this is like a slightly different way of doing that, kind of similar to a function call. The feedback that I got was that someone actually found the concept more confusing because I had explained the sugar, as opposed to, so I was asking, like, hey, and this is someone coming from an imperative background. They're saying, yeah, like once you got into that whole syntax sugaring thing, it started to look like, this is like callback hell, where you have all these nested callbacks. And I was like, well, yeah, but the point is you don't have that because you have the syntax sugar that fixes that. And I said, well, what do you think about async await? Do you have the same barrier there, like with the mental model, or does async await feel kind of more natural to you? He said, oh yeah, async await feels totally reasonable to me. So I thought, maybe we should try teaching it as if it's just async await, or in other words, like, don't explain the sugar in the beginner materials. Maybe later on you can explain, hey, by the way, this is just syntax sugar, just these sugars to this. But maybe for beginners, it's actually easier if you don't explain that. And you just say, well, anytime you want to do an effect, you put the exclamation point and that's it. I think that's really interesting because it's not something that I would have guessed. But it is the type of thing where, you change the language and now maybe there's an opportunity to lower the learning curve even more for somebody coming from an imperative background. And obviously at some point you have to understand the mental model of like, here's what tasks are. And I want to transform them in these ways before I run them to do error handling and concurrency and things. But yeah, maybe it's better for beginners coming from imperative backgrounds if we don't explain that up front.
Interesting. Yeah. Don't show what's happening behind the curtain. Just let it be.
Or at least not early on, maybe later on,
Yeah. Would the compiler error messages be the same regardless of the syntax you used?
Currently they are, although we actually want to try to special case the exclamation point ones more, just to try to sort of present it more in terms of like what you're seeing. When we first built the feature, it was one of those things where we're like, this is an experiment. We don't really know how it's going to go, but we'll try it out, see how it goes. And fortunately, it did seem to go well. So now we can kind of invest in it more. But at first, we didn't know.
Sure. Okay. So this kind of leads into another question that I have. It's about the processes you use to discover new designs. And from the episode of Software Unscripted, guest hosted by Jose Valim, you said, quote, something that I learned from Evan is a good way to think about programming languages, that every programming language is in some sense an experiment, which we were just talking about.
Yeah.
You have a hypothesis that something's going to be good, a good experience, or going to go well, but you don't really know until you try it out and people use the language and then you find out, end quote. So obviously this is an example of that, but is there some, like, how do you get a sense of knowing that it's working out? Do you just kind of gut feel, or is there like some of a more clear process for that?
That's a great question. I would say it's mostly gut feel. So that's a mix of seeing what people's reactions are and then trying to interpret those reactions. So sometimes people will say, I don't like this. It feels weird. Sometimes people will say, this feels great. I love this. But the interpretation part comes in because if I were to look back at a number of changes that we've made to Rock, there's quite a few things where right when we made the change, there was a decent amount of negative feedback, people saying, I'm not sure about this. And then later on, people were like, oh, actually, that was fine. I got used to it pretty quickly. Like I didn't, it was inconvenient because that's the thing is change is always a little bit uncomfortable innately. The question is like, is it worth it later on? So actually currying is a really good example of this because if you ask people who've been using Rock for a while and who used a language with currying before that, actually like much less than 50% of the Rock community has used Elm, which is surprising to me. I would have guessed that it would have been a lot of like, or mostly people who were like, oh, I like Elm and I want that experience in other domains like me. But it's actually a huge number of people who are like, this is their first functional programming language, or maybe they'd like dabbled in a few languages before, and this is the first one they've actually sort of used seriously. But which is great. Like, and I also hope that there can be some like cross pollination there, where I'm like, hey, if you wanted a really nice language for making UIs, you should use Elm. But basically, I have seen a pattern already where people who are used to languages with currying, who try out Rock for a while, they just like forget that Rock doesn't have currying after a while. It's just like somebody new will show up to Zulip and be like, hey, like Rock doesn't have currying. Like, really? Because that's like something I use all the time. And then someone will just chime in and be like, I thought the same thing, but it's totally fine. Like, it's not like you just like get used to it very quickly. Because part of the reason that I had this intuition that would be an experiment worth trying was that I remembered from my experience with Elm, just thinking back on like, how often do I actually use this? And it kind of broke down into two categories. One is obviously the pipe operator I use all the time, and Elm's implementation of the pipe operator relies on currying, but you don't have to do it that way. You can just do it as like the pipe operator is its own thing, which is how we do it in Rock. So you still get the pipe operator, so that part's fine. And then separately, I would like very occasionally partially apply something when passing it to a higher order function. And yeah, it was convenient in those cases, but it doesn't come up that often that it's like I really miss it. And I definitely appreciate the sort of simplicity of not needing to teach it and also not needing to deal with the occasional error, like compiler error message that's like so in Rock, if you don't pass enough arguments to a function, it just says, hey, you forgot an argument, right? Whereas in Elm, it can't say that because you're always allowed to leave off an argument, and that just curries it. And then you get used to the sort of pattern of error message where it's like, if you see this really long type, but one of them has like a slightly different, like, oh no, I forgot an argument. I know what that means. not a great beginner experience. And even as an advanced user, it's just nicer to just see the, like, you forgot an argument. That's it, you know? So yeah, there's trade-offs in both directions, but that's an experiment I think has worked out. But again, there's no like objective way to do that. It's really just kind of like, do I feel that it's worked out? And in that case, I think so. Yeah.
Okay. Cool. So one of the things that I wanted to talk about is you recently announced that you will be working at Zed Industries.
That's right.
Yeah. So the editor, the Zed editor, which I've now started using as a daily driver since
Nice.
the Elm integration is there, and it's just amazing. I was able to go from Atom, which I was still holding on to up until this year, where everybody else had moved on to VS Code, and
Oh, wow.
I just was like, I know it's so close, and then when they opened it up and the Elm integration got in there, I was like, all right.
Well, it's the same team, right? It's the same people who made Atom that made Zed.
Yeah, exactly. So
you really
I
kept continuity there.
Yeah, I guess it really fits with how I like to work. But yeah, I just I find that really exciting. So I want to talk a little bit about how do you hope that change will shape your work with Rock?
So the main thing that I'm hoping that working at Zed will do for me in Rock is that it will teach me about, or will give me some hands-on experience with editors in general, and then also more broadly, like native desktop GUIs. So these are both two domains that I want Rock to be good at, and also two domains that I don't really have any significant personal experience with. So getting to just like sort of do that type of work in anger, like day to day, I think will really help me out with like being able to make Rock good at those things. So I already mentioned earlier, like I had this going all the way back. I had this motivation of like, I want to be able to use Rock for editor integrations, like writing, Vim script alternatives, and like editor plugins and stuff. Also, Rock itself is a language that I want to have this concept of like editor integrations baked in. So I've been saying this for a while, but I have this goal of it should be as easy to write an editor extension for Rock as it is to write a function. Like you type your function, you press enter, you go down a line, and you're like, all right, now I'm going to write an editor extension, and that's it. And when you install a package, you get the editor tooling with it. And this is something that at first I thought we were going to have to make our own editor to do this, and then I later realized that for accessibility reasons, that's actually not true. So basically, the goal is that when you install a Rock package, you get the source code, of course, and you also get the documentation, and then also you get editor tooling that's specific to that package. Like if you have a regular expression package, you have some tooling that'll let you sort of ideally like scrub through and see how the capture groups are working out and stuff like that, and just like play around with that in your editor. And then you can imagine like all sorts of different use cases for like package specific integrations, which is not really a thing in any language right now. At first I thought to do this we'd have to do our own editor, but what I realized is that, well, when you think about screen readers, like somebody who's using a screen reader and trying to edit their code, if we don't design that extension API in a way where by default it's friendly to screen readers, then people with screen readers are just going to be out of luck, because that's how things tend to work in practice. So it's got to be kind of like HTML, default screen reader friendly. And what I realized is that if we have an API for designing Rock extensions that is friendly to screen readers, then it's sort of automatically going to be sufficiently generally specified that it can work across different editors like Vim and Emacs and Zed and VS Code and whatever else. So putting all that together, like those are things that I think I want Rock to have, but I don't actually know how to do that right now. Like I don't have any personal experience in like designing editor extensions. I don't really know like what the different trade-offs are that editors are making, like in terms of how they're running their extensions and what's made available and so forth. And working at Zed should give me a lot more experience with that. Second thing is native desktop apps. Like it's always kind of bothered me, and I talked to a lot of people who are bothered by this too, that you have like a music player or like a chat client or something like that, and it's this big bloated Electron app that takes gigabytes and gigabytes of memory, and it feels like it shouldn't for like what it's doing, especially when you have like Winamp, which apparently just recently they released the source code to that. But I remember back in the day, Winamp just would run on my like 133 megahertz single core Pentium, and it was fine. And now obviously like you couldn't even run like a modern electron based music player on that machine. This is doing the same thing. It's just playing music, one track at a time. So yeah, I would love to have rock be an alternative to those things, but again, that's a domain that I don't really know that much about. And fortunately, Zed is doing that, taking an approach to cross-platform native desktop GUIs that I would want someone to take, which is just going all the way down to like graphics card plus operating system APIs on each target operating system, and that's it. No, web browser layer in between that, just really like the minimum number of layers possible. And so my hope is that we can use that to make a really good rock experience on top of that.
Yeah. Yeah. Both of those are really exciting. So kind of going back to the idea of when you install a package, having the editor have something available there that goes along with that package to interact with it. So do you expect there to be, and maybe this question, it would make more sense if we talked a little bit about platforms as well, because I think I also am curious about the discoverability of those. So maybe you want to talk a little bit about how platforms work and.
Sure. So basically in Rock, we have the concept of platforms and applications. An application being essentially the thing that you're building that gets run. So in Elm, this would be like your elm.json, for building an application. And then you have a platform that you're building on, and that's a concept that doesn't really exist in Elm. The platform is essentially, it's kind of like a domain specific framework in the sense that like, it might be like a game engine, for example. It's like, I'm building a game, so I'm going to pick a game engine platform. Or you might say, I'm building a web server, so I'm going to pick a web server platform. Or I'm building a command line app and pick a command line app platform. Platforms are different than frameworks in that although they sort of provide that sort of domain-specific foundational feel, they do more than that. So they also provide all of your I/O primitives. So for example, if I'm building a CLI app, obviously I want to be able to write to standard out, write to standard error, and read from standard in. But if I'm building a web server app, do I really want a primitive for reading from standard in to be available? Does that make sense? Like, you're handling web requests and something like, hey, let's block on standard in. It's like, that's really not going to go well. So you're making a web server platform and you just probably just don't have standard in as a thing, and you'll get a compile error if you or any of your dependencies tries to like, read from standard in. That's just not going to work. So that's part of what platforms do. Another thing that they do is they're responsible for memory management and like figuring out kind of like how that works. So it's always automatic reference counting, but without going into too much detail, platforms have a little bit more control over how memory gets managed than you do in most languages, where it's sort of like a one size fits all, like garbage collector or something like that. So putting those things together, the goal is that you're able to make sort of an end user experience that, as an application developer, just feels like using any normal language, starting with a sort of a framework type thing. In terms of discoverability, these basically just work like normal packages, except that when you're building your application, you have to say like, this one's the platform. Like among your packages, it's like a little keyword called platform that you say when you're picking your dependencies, and that's kind of it. Then that determines like you get your like I/O primitives and everything else from your platform that you pick.
Okay, cool. So it would be, if you're searching the package ecosystem, you would find the platforms in there as well as a subset of those.
Yeah, we don't actually have like a formal package index yet. Somebody made one. So right now, the way that we do packages, and it actually looks like this is probably what we're going to do going forward too, is that in order to download a package, we have URL-based packages, but they have a security feature, which I have not seen any other language do, but now that we've done it, I think it's really cool, which is that when you specify a URL to download a rock package, the end of the URL has to be a Blake3 hash of the contents of that URL. So the reason I say that's, and we verify that when we download it. So the reason I say that's a security feature is that means if the URL gets compromised, or like somebody tries to, also if somebody tries to make changes to it, like, it also means they're immutable in addition to being like, you don't have to worry about being compromised. Basically, there's no way to do that without turning it from a working URL into a broken URL. So it's like either it resolves, and then you download it, and then the hash matches what was in the URL, or it doesn't, and you get an error, or the URL is down, and so you get a 404 or something. So basically, that's what we have for right now. We're going to extend that to work with version ranges soonish. So we have an algorithm for doing that, which doesn't require an index either. But basically, once we have those two pieces, then the last step is we need an index that you can use to search them. I imagine that we would probably have some way to filter based on, like, I want to just show me platforms versus show me, non-platform packages. But yeah, I mean, in terms of discoverability, that's basically the same as packages.
Right. Okay. Yeah. So the platforms, for me, the mental model was thinking about like platform.worker in Elm and browser.application, and then translating like, oh, okay, well, just what if there were more options that you could pick is kind of, and I know that might not translate directly in terms of how that works, but just that for me was a starting point to think about them.
I see. Yeah, it's kind of unrelated to platform and Elm.
Yeah. But so then would you also imagine that, let's say that you're targeting, like, let's say a Raspberry Pi platform, would there be some tooling that you would hope to have in the editor related to that particular platform?
Definitely would love to have platform specific tooling for sure. So actually, this has already happened. We've had a number of different Raspberry Pi rock apps created already. One's like a little robot that goes around a track, which is kind of cool. Somebody else also made a physical clock where it looks like one of those old school like liquid crystal display clocks with like the little like dashes that make up the numbers. Except each of the dashes is basically like on a little servo, so it actually rotates up and down. To become like active or not. And he made all the logic for that in Rock, which is really cool. So right now we don't have any editor tooling for that, obviously, but one of the things that I've had in mind, and I hope we can get the performance good enough to do this, but I would really love it if we could end up getting, I don't know if it's an Arduino or a Raspberry Pi or whatever, but you have some sort of Rock app that is connected to some LEDs, like some colored LEDs. And then in your editor, you have a color picker that's all done through like an extension that's specific to that platform, or maybe even some generic package, probably a platform though. Then you're able to just pick your color on the screen, and then like in real time, it's changing the LED, like physical LED in the room, and hopefully that can be like really smooth 60 frames per second. I don't know how fast you can get the refresh rate on those things with like if you have to like reflash the thing every time, then maybe that's not going to work. But I would love to try to get that level of user experience if we possibly can. So I don't know if it's possible given the hardware, but hopefully on the software side, at least we can make it fast enough that that's theoretically possible.
Yeah. Sounds ambitious. I love it.
Yeah.
Well, we're nearing the end here. Is there anything you want to talk about before we move on to picks?
I don't think so. Yeah, this has been fun to talk about all these things.
Yeah. So what picks do you have for us today, Richard?
Okay, so one is computerenhance.com. So this is a website I've really been enjoying. It's a course entitled Performance Aware Programming. Casey Muratori makes it. And basically, it's really, it is a paid subscription. And I don't have any affiliation with them, so I'm not getting any money for saying this. But I really enjoy it, and I want to let more people know about it. So basically, it's a way of learning about like how to make high performance programs, starting from like the lowest level, like hardware stuff, and then sort of working up, basically understanding like what the actual hardware is doing. So he gives an example of he starts off writing a little for loop in Python that like sums up a bunch of numbers, and then he goes through and actually like steps through he builds Python from source and steps through like the compiled code, so you can see all the different things that are happening in the course of doing that loop. And then he's like, okay, now let's like rewrite this in C and see how much less work the computer has to do, and then we can write the loop in various like modified ways. And he ends up getting it to be like it's like 10,000 times faster than the Python one. It's really wild. And that's like the module one, right? And then he gets into like really in-depth stuff, and it's just, I found it to be really approachable, and also like a lot of stuff that I never really knew about how to make computers go fast. And it's just been really great experience, like learning from that. So that would be one pick. Another pick would be, and I guess the videos for this are probably not out yet, but I just got back from Software You Can Love conference in Milan. And this was the first conference where we actually had like more than 3 rock people hanging out in person. We had 10 people in the same physical space, which was cool. We all took a picture. So that was like, at this point, the largest physical gathering of rock programmers in one place, which is really cool. It was a lot of fun. We had I gave a keynote, and then there were 2 other people who gave rock specific talks. But also, like, the conference just had a great vibe. It was like one of my favorite conference experiences I've ever been to. And sort of the theme of the conference is about like basically building software with like humans in mind, and like trying to make really delightful software, and not, as opposed to like software for like trying to maximize profit or other goals like that. And it was just a really great vibe, and had an excellent time. And I recommend people checking out the conference, but also there should be videos from that up because they live streamed the whole thing also. Probably well, maybe by the time people are watching this, who knows?
Yeah. Excellent. Yeah, I'll definitely find those if they're out by the time we publish this. Then I'll add those to the show notes, and of course, computerenhance.com. I'll add that as well. Good picks. Well, I have 2 picks. The first one is unrelated to programming at all, but since we're talking about the rock programming language, there's a rock band called Humphreys McGee. They are an improvisational progressive rock band, and they're very heavy on the guitar. There's 2 guitarists, Jake Sinegar and Brendan Bayless, and it sounds really cool together. I think, this is more, I learned this from Aaron Strick. I try to think of the picks that are kind of related to the person that I'm interviewing, so that they're more directed instead of a general pick to anyone. But yeah, I think that's a band that I've seen a lot of times in concert, and I think if you're into sort of rock guitar, then you might like that. So that's one. And then the other one is Brett Victor's work on human-computer interaction. Definitely there's a lot of videos and things that he's done out there that I think, of course, they've influenced the sort of vision I think that you have for rock. And so I think folks want to learn more about that and hopefully advance what's possible there. It'd be pretty cool to check out. So that's all I have.
Nice. Let me sneak one more pick in then, since you mentioned a progressive rock band. Reliqa, Reliqa. They're an Australian progressive metal band, and I've really been digging them. That's like the main thing I've been listening to for the past couple months since I found out about them. Big fan, and they're really cool if you're into that kind of sound.
Okay, cool. Yeah, Reliqa. Check it out. All right, well, thanks to all the folks listening out there. Please rate and share if you're enjoying the show, and thanks, Richard, for coming to Elmtown. Rock on.
Yeah, thanks for having me.